So to sum up the last three concepts that we talked about, y equals mx plus b is the slope-intercept form. Point slope form is y minus y sub 1 equals m times x minus x sub 1. And standard form is ax plus by plus c. And there's little descriptions about each one below it. I really like the first one when it comes to graphing. Moving on. Problem 4 wants us to graph an equation using intercepts. You did do this in Algebra 1. You did it very quickly. I certainly don't like it that much because it can be very inaccurate if you're pretty bad at dividing. But I want to teach you how to graph with intercepts. So there is an x-intercept in every problem, and there is a y-intercept in every problem. So you're going to draw it just like that. For the x-intercept is going to go on the x-axis. Therefore, you need to make y equal 0. And the y-intercept, you need to make x equal 0. And that's how you solve using intercepts. Let's continue. This would be 3x plus 5 times 0 equals 15. Solve for x. This goes all the way away, and you get 3x equals 15, and x equals 5 after you divide. We can plot that now. If you want to write it as a point, it's x comma y, so 5 comma 0. Let's plot it. X-axis over 5 to the positive. 1, 2, 3, 4, 5. Draw a dot. That is the x-intercept, where it crosses the x-axis. The y-intercept is pretty much the exact same, except this time 0 goes in for x. So we do 3 times 0 plus 5 times y equals 15. 3 times 0 goes away because it's 0. So 5y equals 15, and y equals 3. If you'd like to write this as an ordered pair, you write it the x value as 0 and the y value of 3. That will put you on your y-axis up 1, 2, and 3. Please do not make this one point. A lot of students plot the point 5, 3. They go over 5, up 3, and then they go, well, all I have is 1 point. No, 5, 3 is not a point. Those are your two intercepts. So I'm going to get my ruler, put arrows on the end to indicate infinity, left and right, and now you have your straight line. Let's do the got it. Same thing here. Why don't you go ahead, set it up just like we did the one above. I'm going to pause the video. When I come back, I'll explain my steps, but pause the video and I would like you to try to do the left and the right. Don't graph it in case you did it incorrectly. That way you can pause the video and fix it if need be. Let's see how you did on your x and your y intercepts. For the x-intercepts, notice that y becomes 0. That cancels out and you get 2x equals 8. Divide and you get x equals 4. Make it a point and you get 4 comma 0. The y-intercept, x becomes 0. So you do 2 times 0 minus 4y equals 8. The 2 times 0 goes away. Now here's my concern. You see that negative sign? A lot of students forget to bring it down. They just bring down 4y. But it is a negative 4y that equals 8. Divide by negative 4 and you will get negative 2. As a point, that would be x comma y, 0 comma negative 2. Pause the video if you need to make any corrections. Now we are going to plot our points. The x-intercept goes to the right 4. 1, 2, 3, 4. It's where it crosses your x-axis. And the y-intercept goes down 2. Grab a straight edge, ruler, whatever you have, beside of a paper. Get your points lined up as perfectly as you can, and grab your straight line. What I'd like to do with you tomorrow in class is talk about why this might not be the best method for graphing. Again, we'll talk about this in class, but I want you to have some ideas as to why using intercepts might be harder than, and maybe I should write this down. The best way, in my opinion, is y equals mx plus b. Why don't you guys think about why y equals mx plus b is actually a little bit better than using intercepts. As we move on to problem 5, we see our first word problem, and this word problem deals with biology. It says the number of times a cricket chirps per minute depends on the temperature. chirps in 2 seconds are shown below. So you see this phrase up here? That's a very important phrase. It says the chirps depend on the temperature. Well, you have learned that y depends on x. So by simply saying that sentence, they have told us the x and the y. X is the temp, and y is the chirps in a minute. And they've told us that just by saying that word depends. Now, they've given us some information in seconds. We have to change it to minutes, okay? But what we can notice is that you should see that at 40 degrees, there will be 0 chirps. So you can see that if there's 0 chirps in 2 seconds, there's going to be 0 chirps overall. But what's maybe a little more difficult is this 93 degrees. And it should make sense, the warmer it is outside, the more chirps we're going to hear, right? The warmer it is, the more crickets we hear outside. Well, we have to take this 8 chirps. If this is 8 chirps in 2 seconds, you need to be able to use your science skills that you've learned. You need to be able to convert that into how many chirps would that be in a minute. Well, let's get rid of that seconds. You know that there are 60 seconds in 1 minute, right? So we just apply our scientific skills that you guys have learned with your units, and you do 8 times 60 is 480, and that would be, let's see how the seconds go away? I guess I can write it to the side, it might be easier for you to see. That would be 480 chirps in 2 times 1 is 2 minutes. Now we can reduce that, right? 480 divided by 2 is 240 chirps in a minute. Okay, so in a whole minute, when it's 93 degrees outside, there will be 240 chirps. Now that we have 2 points, we're going to be able to graph this and look at a graph of how the number of chirps increase as the temperature increases. So our x-axis will be temperature. It is our independent variable. The chirps per minute goes on the y-axis because it's our dependent variable. It's the one that's changing. Well, my lowest temperature is 40. My highest temperature is 93. I'm going to skip by tens, and that should all fit on here. 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Okay? You can put in the in-between values. It kind of depends on how small you write. I can write pretty small. If you can't, you can skip every other. Whatever you feel comfortable, as long as you get them all on there, okay? So I went up to 100. Now what I'm going to do is my smallest number of chirps is 0. My highest number of chirps is 240. I am going to skip by 20s on my way up. Ready? So this is going to be 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, 220, and my last one, just enough room, 240. Okay, let me zoom in so you can kind of see what's going on. Now I need to plot my different points. And I only have 2 points, but that's okay because 2 points makes a straight line. Over 40 up 0 would be right here on the thick axis. And over 93 up 240. So you can see that you have 2 points. 2 points makes a straight line. We're going to connect them. We won't go any lower than 0 because we can't have negative chirps. Okay, we won't go any lower than 0 over here because we can't have negative chirps. But you can see how it's a linear equation and it goes uphill. The more chirps as it gets warmer. Now it says, what is what is the equation of this line in standard form? All right, now we're going to have to come up, first of all, with what? What is the number one thing when making an equation? You should say, I need to find the slope. You would be correct. So we draw the skeleton, and we put the y values on the top. 240 minus 0, and 93 minus 40. Okay, so we use our 2 points to find the slope. That makes 240 over 53, and we're going to see if that reduces. No, nothing goes into 240 and 53, so that is our slope. Step number 2, you can apply this however you want to. You may use point slope form if you want, or you can use y equals mx plus b. I like point slope form, so I'm going to write it down. Y minus y1 equals m times x minus x1. And I'm going to fill in. That's going to be y minus 0. I am picking the point 40 comma 0, by the way, because it's easier numbers to work with. Y minus 0 equals m, so 240 over 53, times x minus 40. Well, they need this in standard form, so what I'm going to do now is I'm going to get rid of that 0. I'm going to make it nice and pretty and say y equals 240 over 53 x minus 40. Now what I'm going to do is I'm going to clear my fractions because they want it in standard form. Standard form means no fractions. They're really challenging you on this problem. So let's go over here. This is step number 3 if you're following along. I'm going to clear my fractions, and I'm going to do that by multiplying by 53. So if I write a big 53 and a parenthesis in my equation, I can do that. The 53 will go to the y, and the 53 will go to the fraction. Since these are already in parentheses, I will not distribute inside the parentheses for another time. I get 53y equals 240 times the quantity x minus 40. Look how nice that was to get rid of that fraction. And that should say 53y. Distribute in. $240 times 40 is minus 96,000. Now because they want it in standard form, okay, they want it in standard form, I need to take my 240x to the left. So I do a negative 240x plus 53y equals negative 9,600. And that is my equation in standard form. Okay. Part C. An equation of the line at the right of this equation here is y equals 4.5x minus 180. If the temperature is 70 degrees, how many times will the crickets be expected to chirp in 1 minute? Now what you need to understand about y equals 4.5x minus 180 is that that is the same thing as right here if I were to distribute in. Okay? So why don't you draw an arrow and write same thing distributed in. Can you please write that? Same thing distributed in. So I have the same equation. They want me to plug in 70 degrees. Well, temperature was my x, so I do y equals 4.5 times 70 minus 180. So 4.5 times 70 minus 180. See it there? I plugged in my 70 degrees. The crickets will be expected to chirp 135 times. Okay? So we'll write 135 chirps in 1 minute.